The aim of the course is to take a new person, someone of science or chemistry or anything,
related
take
to
them
it.
from a zero level of knowledge, introduce them what is an atom, to, if they carry on with the course, to get to university level knowledge in one place, in one simple to follow structure.
Hello and welcome to the Knownness podcast, the Vault of Knowledge. Hello and welcome to this week's episode of the Vault of Knowledge. Today, we'll be talking to Musa Chaudhry, our subject lead in chemistry. We'll be delving into what chemistry means to him, the lines between chemistry and the other subject fields such as biology and physics, complexity theory, as well as science communication. So thank you for tuning in and join us for this week's episode. Hello and welcome to this episode of the Knowness podcast. Today, we're here with our resident chemistry subject lead expert. So Musa, would you like to introduce yourself?
Yes, I'm Musa Chaudhry. As you said, I'm the chemistry subject lead. But I've been involved with Knowness before in the past as well. When Noor first started up Knowness, around how long has it been? Like a few years ago, I was helping him out with some of the science courses and stuff. Then I disappeared for a few years, and then I got a call from the boss. He's like, come back, join us. So like it was like an Avengers moment.
Yeah.
And I'll assemble all the lads from uni, from school that I hadn't seen in so many years.
Yeah, I was part of it as well. Oh, I'm Iron Man, what are you?
To be fair, I told at uni I played crappy Thor, Asian Thor.
Asian Thor.
I don't know if that's allowed.
All right. Okay, you'll be the...
I don't want to say the actual name of the of our Avengers team.
Yeah.
Yeah.
I don't know if it's copyright or whatever, but you can be that guy, I'll be the other guy. So, unlike Thor, tell me a bit about your history, your background.
My history.
Did you go to university? Are you in university?
Well, so I just graduated a few months ago from the University of York. I did an integrated masters
Why is that
in
funny?
chemistry. I did integrated masters in chemistry. My masters, I specialized in physical chemistry, which is sort of like the physics behind that underpins all of chemistry. Right now, I'm working as a subject lead for Knowness. I don't know why you're laughing. And also as a research assistant part-time. And I'm also universal credit because no one pays.
Let's restart, man. Let's restart.
Bro, it's this guy.
You son of a bitch, man. All right.
Anyway, let's carry on.
Okay, so you said you went to York for university, right?
University of York.
Yep. Fuck, wait, I didn't do it properly, yeah? Okay, so...
It's okay, it's very late in the day.
It is really late.
Carry on.
So you said you went to York for university, right? Chemistry.
University of York, yes, carry on.
Okay, so you went to the University of York.
Good.
Perfect. And how was your kind of experience there with chemistry? Did you find that you enjoyed
actually,
it more? Or?
Wait, my experience as chemistry or my experience in University of York?
Chemistry specifically. Did you find that at university level it was better than what you expected, or was it more interesting? Was it more difficult?
I'll say this: I had a really good experience with chemistry, but I think the department really depends on where university you end up and what course you're on.
Yeah, because every course is a bit different, isn't it?
Yeah, I feel like everyone thinks for some reason that all courses, every university is going to be very similar to each other, but it's actually very different. Every university has a completely different system. I suspect that misconception comes from GCSEs and A-levels.
How there's different exam boards and stuff.
Everyone has just the same few exam boards, the same curriculum, but it really varies.
Is it not standardized by like the Royal Society of Chemists or?
Yeah, there's the Royal Society of Chemistry, not the Royal Society of Chemists.
Oh, sorry for this.
Yeah, sorry. But yeah, they do have some standardization, but again, it's very open. It's more like how many exams, what percentage of the year has to be exams, what percentage of the coursework.
Less about the content and
not actually the content.
Yeah.
But especially for chemistry, for example, like if you don't go to a good chemistry course, you might not even learn all the same chemistry as like a lower down uni or not as a good course.
Somewhere elsewhere.
Yeah. And so I know I'm on the Knowness podcast, and there's like a big careers thing as well. I'll say something about some of the top chemistry universities. I'll say a lot of these top courses, is some a little bit of insider knowledge, I guess, don't actually have very good departments. So I don't want to name any names.
Yeah, but really, that's surprising. I thought they'd be like top
they
of the
don't
line.
actually, because they don't need to, because they will get top students just because of the name of the university.
Okay. Because they'll be like Roster Group universities.
Yes, exactly. So don't just focus.
Okay, so then, fine. Let's say I want to do chemistry and I want to get into a good course, something I enjoy. How do I find that out?
So it does have to be Russell Group is not perfect. Again, everyone knows St. Andrews University is not in Russell Group, for example.
Yeah.
And it's one of the top universities. but you do want like a high-ranking university, look for high-ranking research universities. So researchers is very important.
Yeah.
And then the most important thing is to actually talk to students and see how the course is.
Their experiences, the insights they can have.
Yeah. So
Okay.
I got very lucky because I didn't do any of this.
Yeah.
I was completely
It's freestyle that ended up in a good
I was like
university.
only looking at league tables.
Yeah.
Top university, bam, bam, bang, and the highest ranking university that got me in, that I ended up in, was York, and it just happens to be that they have an excellent chemistry department.
Yeah.
So I got really lucky.
No, that's lucky and it's very good. But I'll start with this, yeah. So chemistry. I hate chemistry. I find it boring. I find it difficult. Why did you end up doing it? Is it something you actually enjoyed? Did your parents force you into it? What's the story there?
Oh, my parents didn't force me into it.
Okay, that's good.
I think it was more
Can't
like
relate.
my parents would have maybe wanted to force me into going into more of a STEM route to become
Yeah,
a
like
doctor
engineer,
or something.
medicine, something like that,
It just happened to be that I liked sciences.
Is it?
So it just worked. Oh yeah, obviously.
And when did you find that? Was that since a young age? University, not university, A levels, GCSEs?
Oh, to be honest, I know this is cliche,
Hmm.
and you made fun of me earlier when I said this to you.
I'll
But
make fun
I
of you
did,
again.
yeah, I know. But I did when I was, I don't know how old I was, maybe like 7. I was
Yeah.
like, I'm gonna be a scientist.
From a
It
young
was
age.
like, this is what I'm gonna do, and I've never thought about anything.
not
else.
cliche at all. It's from
Since
a young
then.
age. I want to do
Exactly. It's true. It's true.
Hey, if it's true, it's true. You know what I mean?
When I was young, I used to like animals. So like our The Great and Powerful Aman Ahmed earlier, he was a big animal guy. I was
yeah,
also
yeah,
a big animal guy. I used to make bestiaries as a kid when I was like 6. Of like
What
I
is
was
that?
a bestiary.
Yeah.
A bestiary is like a dictionary of about animals and stuff. It's just like a classification.
okay,
It's like a
okay,
dictionary with
You
animals.
made your own one?
And I was like, yes. It was like, why doesn't everyone? And there's already existed. There were bestiaries already.
Oh, but at the time you
But I
didn't
didn't think
know.
there was. So I was like, I need to make
So you're
this.
making your own thing.
Yeah,
And
exactly.
then you realized, okay.
Yeah, I just loved animals, like the way
How
they're
did you go from
behaving.
animals to chemistry?
Well, I'll tell you why. So I just loved the behavior, the way they interacted, their adaptations,
Yeah.
their evolution, their classification and stuff. I was fascinated by them. And
Very big chemistry topics
Well,
there.
you see, as I went up in my education,
Yeah,
like
yeah.
I did GCSE and stuff, I realized, wait, to understand animals, I need to understand what's below animals.
Yeah.
So like I need to understand the molecules and the
On like a
stuff
molecular
behind
level.
the molecular level. And to understand that, I need to understand the physics behind it. So very quickly, I was like, okay, if I really want to understand this, I need to know my physical sciences more.
Mm-hmm.
And I thought it was way easier to become a physical scientist who knows about animals than the other
Yeah.
way around.
Okay.
So that's how I ended up doing physical sciences.
Yeah.
Now, chemistry specifically, it was because everyone hated chemistry, like
Yeah.
you. I thought chemistry was a bit more boring than physics.
Yeah.
It was the only GCSE in which I didn't get an A star, a science GCSE that I didn't get an A star in.
Yeah.
And I was like, well, just, if everyone hates this is why I'm going to do this. Just to
Yeah,
prove
yeah.
everyone.
To prove everyone
I
wrong,
can,
baby.
I'm
Yeah.
the man, you know what I mean?
Yeah.
But yeah, I was telling you earlier, I considered during my first year of uni to maybe like change to physics as well.
Mm-hmm.
I don't know. So, which is, again, somewhere where Knowness comes into play because of their whole career thing. And
Yeah. So if you had like access to Knowest beforehand,
yeah,
you get
exactly.
to really see
I
what chemistry was
retrospectively
like.
realized how useful a resource like that would have been.
Yeah.
And yeah,
But if you had it before, would you still have stuck with chemistry?
I don't know, but the thing is, I knew so little about academia. Like, no one in my family really had gone to university, not in this country.
Yeah. So you don't have that insight and
Like,
that kind
only
of
my
stuff.
mom went to uni in Pakistan, like before I
Yeah.
was born. So you know what I mean?
Yeah.
So I didn't really know what I was doing, or during A levels. To be fair, I didn't know what I was doing.
Yeah.
Like,
'Cause I guess you didn't have that any level of like career guidance.
no, it was just there was a lot of people trying to give me guidance.
Yeah.
A lot of Pakistani uncles
Yeah.
trying to give me
medicine,
guidance.
do
It's
law.
like I was like, this does not sound like good guidance.
Yeah. See, if you had Knowness, with the careers guidance,
Exactly.
you would have that.
Which you can actually get to Knowness through Knowness app.
Knowness app, Instagram, and the Knowness website, which is Knowness.
But yeah, so this is exactly why I'm so passionate
Yeah.
about Knowness. And,
and chemistry as well, I'm guessing as
Yeah,
well.
chemistry.
As a part of it.
But
Yeah, 'cause
again,
you had that foundation.
it's
and,
like, it's not just chemistry. I'm interested in all of science.
in the sciences in general, yeah, that's the vibe I've gotten
sciences
as
in
well.
general,
Yeah.
yeah.
Chemistry is just one of the gateways into it, from what you're
Yeah,
telling
it's
me.
also like, it's usually
The
called
background, the basis.
It's called the central science for a reason.
Chemistry.
Yeah.
Oh, okay, I didn't know that.
So people often call it the central because it's got
Yeah.
physics and biology and all other aspects of science revolve
Mm-hmm.
around chemistry. And I thought I could learn a little bit about each one of them.
Yeah.
There's a reason why natural sciences is such a popular course now.
Yeah, I've heard that's a
So
very, very
Cambridge
big
doesn't even
course. Yeah,
teach straight sciences. It's only natural
it's just
sciences.
natural sciences. Yeah.
Yeah, exactly.
And what about your time in university? I think you mentioned before as well off camera that you took a year out as part of your course.
I did took a year leave of
That sounds
absence.
fun. It was New Zealand, right? How did that happen?
Oh, that's a different thing. Okay, that wasn't a year out. That was part of my degree.
Oh yeah, as in yeah.
Yeah.
How did that happen? What was that?
It's just when I signed up initially, I was gonna do a what do you call it? An year industry.
Mm-hmm.
So because that's what everyone tells you. Oh, do chemistry with your industry.
Gotcha.
Like,
Yeah.
employment wise, it's really
Yeah,
good.
extra points, extra that kind of stuff.
Exactly. But there was my career had different like paths, so you could just do. So I did an integrated masters.
Yeah.
Which is bachelor's plus masters together.
Mm-hmm.
Again, I didn't know what the benefits or disadvantage was. I was like, just get a master's straight away.
Yeah.
It's just better. But yeah, so I could have done integrated masters and stayed in York for 1 year extra, or done my masters as in the industry, or done my masters in a year abroad. I signed up for the industry because of the employment benefits of that. You get a career
there's
afterwards.
a lot that comes with
However, early in my education, in my time in York, I was talking about it with my supervisor, Matt Evans, who might be watching this probably.
Shout out Matt Evans.
Shout out Matt Evans, who's a proper G. And he was like, Matt, I was talking to him about it, and he was like, yeah, but you can go and get a job. You will get a job eventually.
Yeah.
That's what an industry is, basically a job for a year.
Mm-hmm.
You're not going to have the opportunity to go for another country with so much support, be paid for.
The
Government giving you
You're
money.
not going to get that chance again, are you?
Having a whole university helping you and securing a job. You're not going to get a chance to a random country where you want.
Yeah.
And that really, it's a good point. Yeah, I'll go do that. It was also like, I'm just not a corporate guy. I just don't like the idea of working big businesses, especially big pharmaceutical company. Or just like a big corporation, just getting lost in the whole crowd of people.
Yeah.
So that's why I decided to go.
And what was it like? Did you think it was worth it? Was it enjoyable?
Oh yeah, it was definitely worth it.
Because I find that's crazy. Like going so far away from home for a year, and New Zealand, that's pretty far.
Yeah. Well, I think I chose New Zealand because I was like, this is far. This is cool.
So
because I wasn't going to go to Germany or somewhere that you can just go there on a holiday, you know?
Yeah. Somewhere that you don't really need another chance to go to.
It was good. The thing is, our course in general is quite intense at York.
Yeah.
Our master's year was incredibly intense.
Well, that's been really tough year then.
It's a very tough year. I didn't leave the city I was in.
Yeah.
It was partly my fault. It was partly because financially it's £2,000 return flight.
Yeah, which is
so as a student, I was like, after that, I can't go traveling in New Zealand now after paying that. But yeah, I was just working really hard. But I did enjoy it. New Zealand's beautiful, as they say.
Yeah.
And the trees look different. It's just, you can tell it's on the other side of the planet.
You can tell you're in a different place, right?
Yeah, I mean,
whereas if you're in Germany, it's like you're in London.
The seasons are flipped because it's the southern hemisphere.
Oh, it is. Yeah.
Yeah. But it was good. It was.
What was your? Was it a project there? Were you working there? What was it?
So it was my master's.
And what was it on?
It was in computational theoretical chemistry. So I have a physical chemistry.
Complicated.
It's not that complicated.
It's not. Break it down.
It's theoretical chemistry is basically the mathematics behind chemistry. It's mostly for chemists. It's mostly quantum mechanics of chemical reactions and bonding, and atom-to-atom interactions.
Mm-hmm.
The computational part is essentially we use these equations, the maths behind it, mostly the Schrodinger equation.
Yeah.
And we use computers to essentially run calculations. So the Schrodinger equation is actually, you can't solve it for multiple electrons, multiple systems. So we have approximations.
Yeah.
So essentially, long story short, we model chemical reactions and approximate them in a computer. And the benefit of that is I don't have to be in a lab 9 to 5 every day, smelling toxic chemicals. Exactly.
Quite the journey. Sounds like quite the journey. And I feel like with you, you've had that journey, right? Because you're not just going from England to New Zealand. You started all the way back in Spain. Is that right?
Yeah.
I
mean, you already know my backstory.
Yeah.
Good segue.
It is, isn't it? So talk to us about that.
Well, I was born in Spain.
Yeah. Because I guess some of the viewers might be able to tell it's a bit of a Spanish accent.
Is there?
No, a little bit. A little bit, yeah.
I don't know.
I'd say so.
I'm a little bit insecure about it, but thanks for bringing it up in front of the millions of people who are going to watch this podcast.
No, it's a nice accent.
Oh yeah, I'm sure.
So how long are you in Spain?
So I was born in Spain in the last year of the previous century, in the year 2000.
Oh, okay.
I was born in Spain. Immigrant parents from Pakistan. And then, I lived there most of my life. So, it's a good place to develop a fascination for animals. Because I grew up in Barcelona. I wanted to be a marine biologist for a while because it's beautiful Mediterranean Sea. There's a lot of science.
It's right there, isn't it?
Research going on. I loved the zoo, the Barcelona Zoo as a kid. And then when I was around 11, we moved to Pakistan for a couple of years, which was a very good formative experience for me, I think. I was a terrible student all my life. I was the worst student in the class.
Always causing trouble.
What was the trouble? The reason?
Always causing trouble, right?
Well, I wasn't causing trouble. I was a nice kid. I just wasn't a good student. I was just dumb. I wasn't dumb. Okay. Well, I don't think I was dumb. Like sometimes I would get like full marks out of nowhere. And sometimes I like completely flopped.
Completely got nothing.
I was not focused. Just didn't care about education. I think when I got back so I was in Pakistan from the age of 11 till 13.
Yeah.
And when I came back, I think my final report in Pakistan was F, D. It was awful. But I didn't really care. Like I didn't really care about education at all.
I guess at that age as well, it's kind of.
Also, the school I was in Pakistan, it was a private school, but it was full of like rich, posh people. No one cared about education there. It was more about.
What about when you came to the UK? Did it kind of change, or was it?
Yeah. Well, so first of all. I thought this schooling was a lot better in the UK than it was in Pakistan. And also, I thought the teachers actually cared about the subject. I thought my science teachers actually really care. And I was still going to be a scientist with crap grades or good grades. I didn't care.
Yeah.
And I really got into it and I received a lot of like positive reinforcement. And I didn't think GCSEs were too hard either. So after 3 years, I graduated middle school with like A stars and A's. Went and did my A levels.
I mean, that's a successful journey.
That's where I met Noor, our CEO and founder of Knownness. At Knownness app.
Instagram.
At all social medias.
And all social media. Knownness.com.
Knownness.com for the website.
YouTube, Instagram, Twitter, Facebook.
It was LinkedIn. Actually I think I'd been in the UK for a week. I didn't speak any English.
Yeah.
If you ask me, I would get confused between people asking me, how are you? Because I would think they said, how old are you? And I would be like, 13? And they'll be like, oh, this guy is so dumb. But everyone's really nice. And how I met Noor. Noor loves to tell this story. I remember, I think it was 3 days. I'd been in the country for a week or so. And I think it was like my third or second day at my UK school, Wheelers Lane Technology College.
Yep.
And I was just sat. So this is the story of how I met our CEO and founder, Noor. This is around 11 years ago now. So we go way back. So I was sat outside in the playground, just having my lunch, peanut butter and Nutella sandwich. Way better than, Jello?
Jelly. I don't understand. Nutella's
overrated Nutella. That's what
I don't understand it. Makes no sense. Assault on the taste buds. So continue.
100%. Anyways, I was just sat there and then I saw this group of students just approaching me. And I was like, oh my God, there's a lot of people around me. I don't speak English very well at this point. Yeah, it's
uncomfortable for your first time in the
uncomfortable
in the UK,
And then I saw Noor. And he was like, I realized then that this guy, he's trying to make friends. He's trying to be nice to me. He's trying to see, he saw me alone.
You to the group.
So, we started talking. It was a little bit intimidating. They started talking about FIFA. I don't know anything about FIFA. So I lied. I said I had Messi on FIFA. I completely made that up. I was like, I'll be a cool kid. And they were like, yo, if you got Messi, you got to sell Messi and you could buy all these other players. I was like, sure.
Works, but
and that's how I met a lot of my friends. That's how I met Noor, CEO founder. So you can see even back then he was a leader. He was a leading man. He was born to be a leader.
Yeah.
But yes, then
that's a very interesting journey.
It's a good story. It's actually a really sweet story.
It's a very good origin story. Going from all the way that to New Zealand.
And again, Noor has had more influence in my life. We went to the same sixth form because of him. We went to a grammar school, King Guiders the Sixth Campbell School for Boys, where I met you.
That's where we met. Well. Yeah, that's the one. Back when you had the mustache.
The mustache. Oh God, that was an era.
That was an era.
And I didn't know anything about education. Actually, I'm remembering a few things that Noor helped me do during my academic career.
Yeah.
He not only got me to go into Camp Hill, because I didn't know about what good schools were or anything. I didn't know what a grammar school was. I didn't know much or had much guidance. But he encouraged me to go, mostly because he wanted one of his mates there. But he also told me it's a really good, prestigious school. They have really good teaching, which was true. And I went there. But I remember we had, between the summer of year 12 and 13, I went to 2 summer schools, one at Oxford, one at Cambridge. And I didn't know anything about this, but it was Noor who was like, yo, Musa, this is summer schools.
Were they beneficial for you?
They were really beneficial. I got a bit of an insight of Oxbridge. It was good for my personal statement for you.
Yeah, for stuff.
And I understood it was the only chance I got to experience what chemistry would be like or science would be like at uni.
Yeah.
But it was Noor who got me into it. He was the one who came up to me proactively, and he didn't get in, but I got into them. So and he helped me for the applications as well. So retrospectively, as I'm speaking about, I'm realizing where Knowness was always.
It was always that whole career guidance,
like the career guidance.
Careers is always that's the kind of the soft origins.
Exactly.
I mean that's a crazy journey. Like I said, crazy journey. And then let's go more into the juice of it. Why are we here today? Chemistry. Talk to me about chemistry. What is chemistry to you?
What is chemistry to me?
Chemistry. Big question. What is it to you?
Interestingly, I have a degree in chemistry, and I've never been asked that in my whole course.
Really?
You would think. I don't think it's that surprising. You know what I mean? But
you would think. You think that.
You think someone would ask you that. I've got all sorts of other questions, but never that question. Chemistry. So on a very simple level, chemistry is the study of how atoms interact with each other. That's it. And atoms and light interacts with each other. I would like to add that to it. And I don't know how else I could go on and improve upon that.
Whatever you think is the best way to describe it. I guess that description,
that's pretty much
although it's simple, it's a good
I want to keep it
description.
simple because there's so easy to go into a tangent. But I feel like that's if you want the answer for what is chemistry,
at the root of it,
just how the study of how atoms interact with each other. That's it. But I'll say this: it's a very interesting scale to study the universe at. So, for example, you might say biologists study it at a larger macro scale. They study whole organisms. Huge harmonies of atoms interacting with each other. Larger scale. Physicists study it at a very deep. Not always, but either at a very small level, at the quantum level, or a very huge level at the, sort of like the space and like sort of astrophysics level. But there's something about just the interaction of atoms that I feel like gives insight into the nature of everything else in the universe. I don't know, in a deeper manner than other forms, other areas of science, which might be a bit biased, but I believe it. So.
If you believe it, that's what you feel, and 100%. And then when it comes to chemistry itself, right? To me, and from my memory, I don't remember too much. I remember there's equations.
Me neither. I don't remember anything.
It's just lost from your memory after university. I kind of remember like the A-level content, right? So when it comes to chemistry, what aspect of it interests you the most? What actually gets you kind of excited to talk about?
I like a lot of chemistry, but as I said earlier, I'm a physical chemist at heart. So I like about the maths behind it. I like the physics behind it. Because again, the way I'm speaking already, you can see I'm interested in the rules of the universe. I'm interested in how things work and why work more than the other areas of chemistry, which are more. It's a very application focused degree. Even though it's a natural sciences, is very much also an engineering subject because you learn how to make things. And which is, again, going back to the careers thing, a chemistry degree is much more employable than a biology or a physics degree because with a chemistry degree, you can straight go into an application. If you're doing physics or biology, that's very theoretical. You need to go and get further training to actually be able to apply your knowledge. Chemistry, they're teaching you how to make stuff, how to break stuff, all sorts of stuff from day one.
Okay, I see. And I guess when it comes to your kind of future plans at the moment, chemistry-wise, what is it? Are you going to do a PhD or what's the kind of plan?
I am currently applying for PhDs. Okay. So so my future was chemistry wise. So I did my integrated masters in New Zealand, which again was in computational and theoretical chemistry, specifically of 1-ethyl, 3-methyl imidazolium tetrafluorobromate.
That one,
which is an ionic liquid, which is a common propellant for ionic liquids in spacecrafts.
Oh, it's like rocket fuel.
I guess you could say it's sort of. It's You could say I'm a rocket scientist if you really want to push it.
For the purpose of this, we'll see.
But I'm continuing. I finished my master's project,
Yeah.
but now I've stayed on as a research assistant
Okay.
to publish that. And I'm really lucky that I'll get to be first author on that publication.
Oh, nice. Okay.
So that's currently what I'm working. So I've taken a year out after uni to make sure I get that in.
Yeah.
And I feel like I really complete that chapter of my life because now I want to move on out of chemistry into a chemistry-related area of neuroscience. That's where I'm applying PhDs
Oh, yes.
in.
I mean, I would say it's a bit of a jump, but not really.
I wouldn't say it's a bit of a
Yeah,
jump,
yeah,
but
it's still very related to
as
chemistry,
you said
isn't it?
earlier, I don't care about the specific field of science specifically. I care about all of science, and I'm interested in all parts of it. So
Yeah.
I feel like that publication will be me closing the chapter on chemistry, and I hope to open a chapter in neuroscience if I get a
neuroscience.
PhD. Fingers crossed.
Fingers crossed.
Yeah,
Yeah, hopefully
yeah.
you get into that. Yeah. I remember, like, when it comes to chemistry as well, what would you say, is your favorite aspect of it? Like chemistry itself as the degree. So what did you enjoy the most?
I mean, there's so much. There's a few things that come to mind. My first love in chemistry was quantum chemistry.
That sounds complicated.
It's,
What is it?
it sounds complicated.
It does
What is
quite.
it? Very leading question.
Yeah.
Okay, what is it? So it's the easy answer is the quantum mechanics of chemistry.
Yeah.
So how physicists at university usually study quantum mechanics is usually very in depth, but in very simple single atom, single electron systems. Our quantum mechanics of chemistry is all about how, because it's chemistry, it's how about multiple atoms, multiple electrons interact with each other. And I just thought, I was like, again, going back to my original goal with physical science, was I want to know how things work at the very,
at the
very,
root of things.
very fundamental level. And that's why I wanted quantum mechanics. Also, it was strange. It was cool. It was a little bit edgy. I don't know.
No, it does. It does have that sound, like
It's just
quantum
mechanics.
quantum mechanics.
Yeah, and I went into chemistry because no one else liked it. No one in my chemistry course liked physical chemistry.
Yeah.
Very few of us liked it. No one liked quantum mechanics. Everyone wanted to do organic or inorganic chemistry or analytical chemistry. So there was like, I get to be
Bit different.
but
Yeah.
But
you did
a bit
enjoy
basic,
it, though, right?
But
Yeah. But you did enjoy it, though, right?
I loved it. Yeah, it was
Yeah,
fascinating.
yeah.
I was writing a course for Knowness yesterday.
Oh, is it? Is this the chemistry taster
The
course?
taster course, and I was writing about quantum mechanics in it. So I
Okay.
got it all memorized right
Yeah,
now,
'cause
fresh
it's
in my
nice and
head.
fresh. Yeah. And that's available on the Knowness website, Knowness app, on Instagram, TikTok, Facebook, LinkedIn, Twitter. So tell me about this course.
You want to hear about the course?
Yeah.
So it's a taster course.
Because when you say quantum, is it quantum mechanics or is it quantum chemistry?
So I'm talking about quantum chemistry, which is
So
an area of quantum mechanics.
So quantum chemistry, right? I have no idea what that is. If I wanted to kind of understand what that is and get a brief overview of what that really entails, what it means, would I be able to on this taster course?
Oh, 100%.
Okay.
100%.
'Cause that's something I
Now,
actually want to have
I
a
will-
look into.
I will
'cause
say this.
It sounds complicated.
I will say this. It is, you've done A-level chemistry.
Yeah,
So it'll be,
hated it.
you hated it, but you'll definitely be able to do this.
Mm-hmm.
It is a taster course focus of people who want to go study at a degree level chemistry,
Gotcha, yeah,
who
yeah.
have A-level or IB
Some prior
chemistry. Yeah, so there might be a little bit more that you have to know. You have to just know what energy levels are. And after that, you'll be able to understand a little bit of it. But one of the main things I'm trying to do in this module, in the first module of the taster course, is to explain the principles of quantum mechanics, why, even though it sounds intimidating, is actually based on some very simple concepts.
Yeah.
That the maths of it is very complicated.
Cool, I
but
can imagine.
you can qualitatively, just the idea and concepts of them are actually very simple
Yeah.
to understand. So you should get on the taster course once it's ready. Hopefully
Yeah,
I'll get
yeah.
it done soon.
Yeah. No, that's something that sounds very, very interesting. And I'm sure a lot of people, either watching this or listening to this, would find that interesting as well. Gives you a nice little insight into what chemistry as a degree.
100%.
And I'm sure, like you said earlier, that would have been something you would have found super beneficial.
Yeah, I
prior
would have just
to-
found it interesting just to read
Even
about.
just interesting, yeah. I find it interesting just to kind of see, because from my background, it's very different to chemistry and what it's taught. So it'd be interesting just to kind of see what it's like.
Yeah, also like GCSE chemistry is nothing like A-level chemistry.
Yeah,
And A-level
really
chemistry
completely
is
different.
really nothing like uni chemistry.
I've heard, yeah. It's on another level.
So yeah, I think the whole idea of taster course at Knowest.com is actually they're very beneficial. It's just a really good idea.
Yeah.
And I've gotten a lot of feedback from other friends I've been talking to about it. It's like, yeah, this would have been really helpful.
The taster course.
The taster courses and stuff like that. Just
what
very
about
well for that.
when it comes to Knownness, the actual general subject courses?
So
for
yeah,
chemistry?
so there's a
How
career
is that
guidance aspect of Knownness, but there's also like a general learning guidance of general learning. So anyone, this is not if you're wanting to go a degree or do A levels or whatever.
Anyone
it's just if you just
and,
for the love of learning want to learn a subject on your own time.
Like the other ones as well, biology, medicine.
Exactly.
Yeah.
So I've done online courses. I've done online courses in neuroscience, coding, science stuff, and they're all a little bit gimmicky. They're all a little bit like, just trying to get you. I don't want to say names, so I was about to name a few platforms.
Yeah, we'll save the names for later.
But they're a little bit low resolution, not thorough. They're more about giving you. They give you a feeling like you learned something, but not at a deep level. You're gonna forget tomorrow. Yeah. The aim of this is like we want to be it has to be as simple as understandable, conveyed the best way as possible, which we can do because it's a self-paced model.
Yeah.
And we have the time, and we're not constrained by having to give this many lectures by this time and exams. We have the time to develop really good resources, both text, video, audio resources for people. But yeah, the aim of the course is to take a new person, someone who completely, this is the general course, has no prior knowledge of science or chemistry or anything
related.
Take them from a zero level of knowledge, introduce them what is an atom, to, if they carry on with the course, to get to university level knowledge in one place, in one simple to follow structure.
And as you know, I've mentioned before, it's kind of like that learning journey, starting from scratch all the way to expert level. And anyone at any age or background can access it, right?
Yeah. Exactly, 100%.
And we have a GCSE section as well for specific towards schools and GCSEs.
There's three aspects of Knowness. There's the careers guidance, general learning, and then specific academic tribe learning, which is, for example, GCSE revision guides for students. We have all different exam boards at the moment for all subjects. We're going to be having A-level revision guides soon for all different exam boards in the UK. And so that's the three aspects of Knowness. So really, it's the really ultimate educational platform.
Yeah,
you can really learn all different at all aspects. If you want to learn
at all levels,
if you want to get educated, Knowness will always have something to offer.
Yeah. No, I think with your expertise and experience, I think it'll be very helpful. Yeah, as well as your passion for chemistry.
Yeah, which is science.
Yeah, which is good to have you on board as well, because a passion is what kind of really drives these courses. It's not just a tick box exercise for you. Your passion is. You can
this
see
is one of the
well.
things Noor said, our founder, early on. Like because we're hiring subject leads for different subjects, and I have a friend who did chemical engineering at Cambridge. We're like, it'll be a great subject lead. But Noor asked me, "Is he passionate?" I was like, "No, he hates chemical." It's like, we're not hiring them. So it's like, you can understand. There's an understanding that passion is what drives real learning.
100%. Yeah, and you can tell the difference as well between a passionate teacher or a lecturer and
when you read the notes, when you read the courses, you will be able to tell the passion behind it.
Yeah, 100%. And when it comes to chemistry as a whole, right, moving forwards, is that something you still want to be very heavily involved in? Because I know you mentioned you want to move kind of towards the neuroscience side of things.
If you want to get deep, so I'm interested. So for a long time, if you look at the history of science, scientists were polymaths. So Isaac Newton, for example, he was known for physics. He essentially invented classical mechanics, classical physics. Newton's law of motions, everyone knows. Also discovered calculus. Was one of the first two people who simultaneously discovered calculus. Yeah. So he was a physicist and mathematician, but he was also known for his alchemy experiments. So he was also a pre-generative, pre-chemistry guy. Yeah. And then we moved on very quickly, in literally 1 century, to very specialized chemistry, biology, physics, material sciences, earth sciences, really specialized. And there was a lot of discoveries then. So two things. One, personally, I prefer being a generalist, knowing a little bit about everything. Yeah. And secondly, it seems like at the moment, the new frontiers of science are going to be in the intersection of different academic disciplines. It's not about specialism. You can see, you can see, for example, theoretical physics has completely changed the world. It was completely drived our economy, our whole world in 20th century. But in the last 60 years, not much has happened in theoretical physics at all. So the next frontier, which I am really passionate about, is something called complexity theory. So complexity
Sounds
theory.
complex.
Yes. So complexity theory is something that it's a bit self-explanatory. It's how simple things, from mathematical level, how simple things, just by pure randomness, become really complicated things. So how simple atoms become molecules, molecules become the first living organisms, which become bacteria, which become biology, which become living organisms. And if you look at our models of physics at the moment, physics doesn't predict the emergence of life, but life is here, everywhere.
We still see it.
It needs to. So, and this is something Schrödinger, the inventor, one of the OG inventors of quantum mechanics, wrote. He wrote a book called "What Is Life," and it was all about this. It's like our models of physics don't predict the emergence of life. This is one of the reasons I want to go into neuroscience, because I have a strong background in the physical sciences. And neuroscience, the study of the brain, is probably the most complex object in the universe that is biologically made, or that we know of.
So far. But by far the most complex.
By far. And I think I'll have a chance to merge these two disciplines, because neuroscience, a lot of systems and complex, a lot of genetics. It's all the complex systems we know. It's like genetics, the brain, neurons, and the physical chemistry background into formulating, better understanding how complexity in the world functions. So in order to do this, I've already contacted someone called Lee Cronin at the University of Glasgow. So Lee Cronin has recently published a paper on complexity theory on Nature, actually.
Okay.
And he actually offered me a PhD under his lab to study. Yeah, he's a chemist as well. But one, I do really want to do neuroscience and then come back to complexity theory. Two is in Glasgow, and I can't do the winters. I was in Europe and I died in the winters. I just can't do the Glasgow winters. But it's a fascinating paper. If anyone's interested in science, please go read his paper on Nature. I forgot what it's called. I used to know it by heart. But it's on complexity theory.
On Nature.
It's on Nature. And I think the abstract starts with, neither do the laws of physics predict the emergence of life, but neither does evolutionary biology tell us what is the fundamental physical driving force of evolution. And that's somewhere a chemist can really have input in, because we live in the intersect of both fields.
Gotcha.
So that's my interesting. That's what I'm interested in.
No, I can tell you, and that does sound really interesting. But how if someone was to ask you in layman terms, what is complexity theory?
So I sort of really explained it, but in a really waffly way. I think so. Who's Wolfman? I forgot who wrote that book. I forgot who it was. But there's this called, I forgot what it's called. The Game of Life. That's what it's called.
Gotcha.
You know what the Game of Life is?
I have no idea.
Okay, so you haven't got me then. So the Game of Life is like it's essentially, I think it's called Game of Life. It's essentially a computer simulation. It's very simple. It's basically a 2D on a computer, a 2D plane. One pixel, and you give that pixel very simple rules. For example, if there is it's one black pixel on a white plane, and they use very simple rules. If there's if there's two or three neighboring black pixels, make another black pixel. If there's less than 3, die or disappear.
Less than 3 pixels around it?
Around that one pixel.
Gotcha.
So there's 1 to 8 different places it could be on a square grid. That it could be. And it's a very simple game, very simple rule. And if you just put 2 or 3 pixels next to each other randomly, you leave it go, come back, you see almost organisms have emerged.
I see.
It's a very simple. So it's a very simple rule. I wish I had a video to show here.
Yeah,
but you can see this weird, almost like machines forming that have the ability to self-replicate, and they start interacting with each other, making bigger and more complicated machines and stuff. Now, what is the mathematics behind that?
I wouldn't.
I have no idea. No one knows. So no one knows.
Oh, no one knows.
No one knows what the maths behind is, but it is a phenomenon that happens.
Yeah.
So what is the maths that dictates the emergence of complexity from simple things? Yeah. So if you want to go, if we have time on the podcast, we can go a little bit deeper. We can spend more time on it.
Yeah. No, that sounds very interesting. That's something I kind of want to revisit and look into later on. And was there a book you mentioned related to that? Or?
So the first book I mentioned is, I think it's called What is Life by Schrödinger. Schrödinger's Equation.
Yeah.
I don't know if people want to read that book.
I want to read it.
The second book I talked about is where they talk about this, I forgot what they actually called this game of life thing.
Yeah.
I think the book is called The Emergence of a New Science. I feel like this, if a computer scientist was here, would know. It's the guy who made like some really important computer science thing. His name is like Wolf something.
It rings a bell, but I don't.
He's got a big company, but it's called The Emergence of a New Science, and it's sort of one of the most important books on complexity theory, more from a computer science point of view. If you're interested in complexity theory, go read Chaos. It's just called Chaos.
I've seen this book. So yeah,
it's a really popular book, but it's a really good book. It's a little bit pop sciencey, but it's the best introduction
into like
to complexity. You know, you got like fractals, pretty things, all sorts of things.
Yeah. No, that's super interesting. That's definitely something I want to look into a bit further on.
Well, are you actually interested? Because early in the podcast, you were like, "Oh, I don't know. I'm going to ask you about chemistry. Chemistry's boring. I like the biology guy more."
I think my image of chemistry is very restricted to A levels, and it's not for me, not particularly exciting. But I guess everything that stems from chemistry, like complexity theory and some of the other things you mentioned previously as well, that stuff's interesting. That stuff's kind of a bit more.
That's interesting.
More up my alley, as they say. I think another thing we spoke about briefly as well before the podcast was about your interest in, was it like science communication?
Oh, yeah.
Talk to me about that. What is science communication?
It's what I'm doing right now.
Yeah.
Science communication.
It's a good way of explaining it.
I'm really interested in.
Yeah.
So when it comes to, that's one of my passions. So after I want to do a PhD.
Yeah.
It's one of my dreams. It's a good way to learn how the whole paper writing science process actually takes place.
Yeah. It's like best way to get hands-on experience.
I am very against actually staying in academia for several reasons. That's a whole other conversation. So one of the avenues I want to go down is science communication. Yeah. So, when you think science communications, the first few people might pop in your head is Neil deGrasse Tyson.
Yeah, I was going to,
And I love Neil deGrasse Tyson. I think it's
like Bill Nye or
Bill Nye,
like
the science guy,
it's a couple on YouTube, but yeah.
There's a lot of people. There's SciShow is a great resource by Hank Green. Lots of really good Blazing podcasts and stuff. The thing is, I feel like they're all a little bit superficial, some more than others.
Yeah.
A lot of them are very fact-focused. So fact. They're not as theory-focused. They're not actually understanding how...
Like not many discussions about things.
Yeah, it's not like on a deeper level. It's very like, oh, this cool thing, star blows up and this happens. Fact-focused.
The end.
It's not theory-focused.
Yes.
And I feel like understanding the theory behind things is what will change your outlook of your life, of the universe that we live in.
And those discussions surrounding them.
It's a little bit like, you open some of this astrophysics. Astrophysics for some reason has taken the science communication thing.
It really has.
And I think it's because like, oh my God, black hole, event horizon, supernova
I guess it's one of those things
explosion.
where people look at it, they see a big scale where like black holes, or they see things in sci-fi movies,
and it's
like
cool and
wormholes
and
stuff like that.
fascinating.
Yeah, it's cool, it's fascinating, but no one really knows what it is, unless until they see videos like this that kind of explains it.
Yeah, exactly.
Or like the sun, those videos where it's like the sun will blow up in 10 billion years or whatever.
So I want to, again, as I said before, I want to go into science communication.
Yeah.
And at a level that's a little bit deeper, but it's still definitely.
But can you give us an example of what something is that you want to, let's say you were to open up your own science communication.
So I do. I want to start a blog on Substack, but I'm just procrastinating. I've been procrastinating for years.
I'm sure you'll make a couple of blog posts on Knowest.com, Knowest app,
will.
Instagram. and the website.
Great website.
Yeah, great website. That's a great website. What are some things you'd want to kind of talk about? Well,
Well, I mean, there's so many things that
I guess complexity theories. I know it's kind of overwhelming. It's a big question, but I guess complexity theory is one of them.
The first thing I like to explain, I think the first thing I would love to explain to, and I guess this is my opportunity to do so, is a little bit of what quantum mechanics is.
I wanted to ask, because quantum mechanics, when you mentioned it earlier, I still don't really have a firm understanding of what it is.
So again, this is where I think some of the modern science communication has done a disservice, where it's like quantum mechanics is this really complicated thing that's really weird.
Yeah.
And only really smart people understand it. Bye. That's literally the gist.
That's the vibe.
I feel like that's where everyone gets, even though it is weird, but it's weird in very specific ways. And I think it is a bit dangerous the way people talk about quantum mechanics, because I've heard a lot of people who think that quantum mechanics is a mystical thing.
I was in like
wishy-washy,
kind of pseudoscience.
Like pseudoscience, people think that quantum entanglement.
That's kind of the perception I have at the moment. It seems like a very theoretical based.
Yeah, but I mean, it's real. Our whole world is based on it. Our computers are completely based on quantum mechanics. The transistor was invented because of our understanding of quantum mechanics.
Okay. So
everything is based in quantum mechanics.
How would you explain it in layman's terms?
So I have to. It's again, the maths behind it is complicated, but the concepts are not that hard. So very simple. What does the word quantum mean in quantum mechanics?
Yeah.
So imagine you have an atom.
Yes.
And you have electrons in an atom.
Yes.
Now the appropriate way of talking about it will be the energy of the electrons in the atom. But I think a more understandable way of talking about it is the distance between the nucleus of the atom and the electron in the atom. So you have your nucleus, ball of positive charge.
Yeah.
Think about the electron for now as a ball of negative charge. And what is the distance between them?
I mean, I can't give you an exact number, but
they have a distance between them.
Yeah.
In quantum mechanics, that distance is set.
Gotcha.
Okay. In the real world, if you had two objects, you can move them closer, further apart.
Further away,
In quantum mechanics, it's set. It's quantized. It can another electron can exist at a further distance, but it's a very specific distance that will be always the same for all electrons in that position for that specific atom. You can't have between these two electrons, for example, you can't have a third electron in between. That's not allowed. It's just not possible. It's a quantized distance. It's not. There's no continuum. Again, in real life, you and I can get close to each other or further away from each other.
It's always up and down. It'll be closer, further
exactly.
away.
But that's the point. It's set.
It's set, quantized,
and that's where the whole idea of quantum mechanics being strange is because nothing in our physical world and everyday life behaves that way.
Imagine
if I tried to move close to you and I physically couldn't.
Yeah.
And I could move far away from you. And if I did that, I teleported a meter behind, but I couldn't be in between those two distances.
Exactly like 1.5, for
exactly.
example.
So that's one way. So now keep on thinking about the atom. So atoms have shells. Don't worry about a shell. It's just like...
I know what a shell is.
Yeah, I know what a shell is, but our audience might not know what a shell is.
That's true.
So you have the nucleus of an atom. Then let's say the electrons around it. So in the first shell, you can have a maximum of 2 electrons. So 2 electrons can be distance x from the nucleus. Then the second shell, which is distance x plus something larger than x, you can have 8. 8? 6, 3, 6, 2. Yeah, 8 electrons.
It is. I was gonna say.
Yeah, it is 8 electrons.
Chemistry expert.
And then I'm gonna mess this up. On the one after, you can have 16 electrons. Okay, that's another example of quantization. There's always 2 electrons. On the first shell, there will always be 2 electrons. Third shell, there will always be 8. Did I do it right?
I think so.
Yeah. Okay, and then there will always be.
Isn't that reflected
16,
in real life as well, though?
How?
Because when I've learned chemistry, it's always 2 in the first shell.
Yeah, that's what I'm saying.
Oh, that's part of quantum.
Yeah, that's part of quantum. But why is it always 2? Why couldn't it be 3? Why couldn't it be like 2 and half? One electron's half here,
yeah,
half
one's
here.
half in, one's half out.
That's another example of quantization.
Gotcha. So that kind of model's been quantized.
So that's what quantization means. Now, the second thing that you have to understand in quantum mechanics is that it's a probabilistic theory. You might have heard about this. It's a probabilistic theory. So this is where, again, because we don't have any real life analog to how this behaves, we need to we can use like abstract examples or other ideas to model what really is happening.
Yeah.
So that was a bit wishy-washy. I'll give you a bit more concrete example. So think about an electron. People usually think about an electron as just a ball of negative charge.
Yeah, that's how I see it.
That's how you see it. You might have heard of this thing, wave-particle duality.
Nope.
You've not heard of wave-particle duality?
I've never heard that in my life.
Wave-particle duality is the idea that all particles of matter in the universe also can behave as waves or are also waves at the same time.
Gotcha.
So if you have an electron, it will behave as a particle in some situations. And in some situations, it will behave like a wave, like a sound wave.
I do remember
like a
something
water
about
wave.
this. Yeah. This does ring a
And
bell.
the thing is, in reality,
Yeah.
it's like we don't really know what the electron really looks like. You know what I mean?
How it looks
We
like,
just
how it
know that
behaves.
sometimes it behaves like a particle, sometimes it behaves like a wave. So how we do it in science?
But we don't have like a picture of it or anything like that.
Yeah, because you can't really have a picture of it.
Exactly, because
Yeah.
it's literally it's too small.
It's too small and it's
I mean, the most
a
you can
little
use,
bit
I think
abstract.
this the highest resolution is like an electron microscope. But that
yeah,
uses
where you can see
electrons.
individual atoms, but again, you will see them as balls when it's convenient for them to look like
Exactly, and other times there's waves, you're not going to
balls.
see
So
it.
what we do in science, we just
quantize
we
it.
we used
I love saying that
we
word.
look at we treat them as particles when it's convenient to treat them like particles,
Yeah,
and we treat them as waves when it's convenient to treat them like waves. That's it.
yeah.
There's no reason to go any deeper than it. So sometimes they behave like waves, and sometimes they behave as particles.
Gotcha, yeah.
Now, when it comes to the probability aspect, electrons in an atom, we're going to think about the simplest atom, hydrogen.
Yep.
So that's one proton, one ball of positive charge, and one electron, one ball of negative charge. Now, in this situation, it's not convenient to think about it. The most accurate way to think about it is not as a particle. It's technically like a wave, but for a general audience, the best way of thinking about it is as a cloud of negative charge.
Oh, I think I've heard it described that way
So
before.
think
yeah.
about the proton as a ball of positive charge inside the atom. The electron is this cloud of negative charge around the proton.
Generalized kind of
It's just
area.
just spread out. It's just like
Yeah.
negative charge spread out. And it's more concentrated closer to the proton because positive attracts negative.
Yeah.
And it spreads out through
Kind of
space.
around,
It
yeah.
becomes less dense as far away.
It's very
So-
different to just the ball method.
Yeah,
of
exactly.
Electron, yeah.
And again, it's sometimes it does behave like a ball, but
Yeah.
in reality, it doesn't look like it's not a ball, a wave, or a cloud.
Yeah.
It's something else. But
we
we
don't
just
really
use the
know.
model that's convenient for us to describe it best
Exactly, yeah.
for our human heads to wrap ourselves around.
You could say you quantize it.
Yeah, we quantize it.
Quantize
It's
it.
not technically correct, but okay.
I like saying it anyway.
It does make you sound smart. It's
No,
like
it really does.
Ant-Man where they just say quantum.
Yeah,
everything- they-
slap
there's like a
quantum
joke in
anywhere.
the
Yeah. And it sounds smart.
But going back to the cloud,
Yeah.
this cloud, what does this cloud mean that's more dense here and less dense here? What it really means, what it really tells you in the Schrödinger equation is that the density, it's telling you the probability. Let me step back. So how do we interpret this cloud is we use something called the Born interpretation. So there's a bunch of interpretations of quantum mechanics.
So is the Bohr interpretation the main one?
So the Bohr interpretation of quantum mechanics. Now, again, we have these equations that tell us that the electron is sort of like a cloud around the nucleus, positive charged nucleus of an atom. The Bohr interpretation tells us that what this cloud represents is the probability of finding an electron at any given point in space around the atom. What does that mean is where it's more dense, this cloud around the nucleus, for example, in the hydrogen atom is more dense, closer to the nucleus and further away, then the probability of finding an electron closer to the nucleus is higher than finding it far away from the nucleus. So this is the second aspect of quantum mechanics. One is quantization, and two is it's a probabilistic theory. It can never tell you exactly where the electrons are, or that's maybe not even the right question to ask in quantum mechanics, but it can give you a probability of where it might be. Now, again, this is where the strange scientists try to describe it as really strange, and it gets a bit lost in translation when it comes to the media. But again, it's strange because it's probabilistic. Nothing in real life is probabilistic. You know? If I grab something and I drop it, if I know everything about the initial conditions, I can predict 100% through classical physics where that ball is going to come down and how it's going to bounce and everything.
Yeah.
You can never do that in quantum mechanics, not because you don't have enough information, but because the fabric of reality itself is not defined. It's probabilistic.
Gotcha. It's like uncertain.
It's uncertain.
Yeah.
And these has other weird implications because there's cloud of electron, I don't want to call it electron density, it's a bit too advanced. This electron cloud, actually, it gets thinner the further away you go from the nucleus, but it doesn't stop.
Gotcha.
So technically, there is a very, 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 very small probability, according to the Bohr interpretation, that the electron will be a distance infinitely away from the nucleus of the atom.
Gotcha. Yeah,
so that's another place where if you follow what the equations say and the Bohr interpretation, which is how we interpret the equations, this is not something. It's a very weird result you get that an electron can be infinitely away from the nucleus of the atom. So that's another way quantum mechanics is a bit strange.
Yeah. That's very interesting. I feel like it's very easy to kind of lose yourself in this and get lost in the source.
Exactly.
This is very random. Have you seen Jurassic Park, the first one?
I have. I don't remember it very well.
Yeah, because there's a character in it, and his whole thing is that I think he teaches or he's got a very big relation to chaos theory. Is that the same thing as complexity?
Who's he played by Goldblum?
Jeff Goldblum. He
I
plays
love
a
Jeff
character.
Goldblum.
I love him. He's amazing.
Amazing guy.
I want to meet him one day. But he plays a character. I love him. He plays a character. He's a pretty good actor.
Yeah.
Who has this whole thing with chaos theory? Is chaos theory and complexity theory similar or
very
same thing?
Similar ideas. Chaos theory is more of a mathematical.
You mentioned about chaos, and that's what got me remembering this whole idea.
Chaos theory is a very similar idea.
I've always thought it sounds so cool.
They have to be unified in a way. I mean, it's more of a mathematical idea. It's very common in computer science. So chaos theory, I mean, the classical, actually, I want to move back to quantum mechanics after this. Because I got an interesting thing to tell you about. So the classical example of chaos theory is the butterfly.
Yeah.
One butterfly does something here in the middle of nowhere, like it moves its wings and the wind generated by it causes a chain reaction that leads to a hurricane happening. Now, that's not exactly how hurricanes form.
Exactly, yeah.
But it gives you the idea that one small thing in the past can lead to a chain reaction that leads to something massive
down the line.
That's the chaos theory. So you can see it's complexity theory, which is the idea that randomly small things happen that over time they snowball into a massive final effect, into a massive thing, like life emerging.
So the difference is randomness. Is that what you're saying?
What do you mean?
So what's the difference between these two different?
They're not a different thing.
Oh, it's the same kind of.
They're the same thing. It's just when you're talking about chaos theory, you're thinking about more
of the mathematical side of things.
It's more of a mathematical concept, yeah. But again, it's like what I was saying earlier, that the sciences are a bit. They're so specific to certain disciplines, and we need to find a way to kind of unify them.
I want to ask you a question about that, but we'll save it for after. What was the thing you wanted to mention about?
So I give you the example of the butterfly, which is a common scientific thought experiment.
Yeah.
A very common thought experiment in quantum mechanics is Schrödinger's cat.
When you mentioned Schrödinger earlier, that's what came to my mind.
So the whole idea of Schrödinger's cat, it's a misinterpretation, I feel, often the way to think it. I feel like people think of Schrödinger's cat as a way of thinking about how, it demonstrates how weird quantum mechanics is.
Yeah.
That's not what the purpose of Schrödinger's cat was. The purpose of Schrödinger's cat was a way of Schrödinger explaining how quantum mechanics doesn't make sense. Or the interpretation that we have that it's that's a probability-based theory doesn't make sense. And because in the thought experiment, what he's saying is essentially imagine that you have a cat inside a box.
Yeah.
And there is a, what do you call it? There is some sort of like alpha decay, a timer that will a random timer essentially.
And randomly set off some decay.
But don't worry about the alpha decay. Just imagine it can randomly at any point inside the box, a toxic gas can release, which will kill the cat. And if we think about this being the electron in the atom, what would we say? Saying that the electron in the atom, the quantum mechanics tells us that the electron is a probabilistic theory and the electron can be anywhere. And it will only be decided where the electron will be after the action has happened, after the reaction has happened, after something has happened, for example, is the same thing as saying that the cat inside a box is partly dead and partly alive in a weird way. It's not one or the other.
Gotcha.
In the same way that we're saying that the electron is not in one specific place or another place, probabilistic, that's almost like saying the cat is partly dead and partly alive at the same time. Yeah, and that's a criticism of the Bohr interpretation. A really popular interpretation now is the many universe interpretation that's really making its way through Marvel and through science. As it's the idea
especially
that
through Marvel, yeah.
through Marvel is the idea that it's not a probabilistic theory. It's whenever what happens is both possible probabilities, whether it's A or B, electron goes here or here, always happens. It's just when it happens, it splits into two different universes.
Gotcha. Yeah.
Which it's quite popular now, but I would say it's a little bit, when it comes to these things, I feel like it's better to just stick to we don't know, but this is just how things behave, than to start inventing this weird hypothesis of universes splitting and this happening. It's like, possible, we just don't know. And I feel like as a scientist, you're meant to say that.
We just don't know. We just don't know.
So that was the cat.
That's very interesting. The thing I was going to mention earlier was, okay, I'll give you an example. So if you look at night and day, there's a very clear distinction between them, all right? But there's no...
Yeah, okay.
But we can't really tell the exact point it switches from night and day, right? It's kind of that gray area in the middle. But still, we still know the difference between night and day. What's that kind of like with chemistry, right? Because traditionally, with the GCSEs, A-levels, that kind of stuff, we have, when it comes to science, physics, biology, and chemistry. So my kind of question is, what do you think, where is the line drawn?
There's no line.
You don't think there's a line? Do you think it's... So what do you mean? Is it like kind of like a blend of everything?
Yeah, I think the reason physics, chemistry, and biology were separated, it was a very recent phenomenon. As I said, Isaac Newton as the example I gave, but many other people, Galileo, for example, were polymaths, and they didn't separate, and they were specialists in very different areas, and they found their way to connect them.
Yeah.
I think it definitely... It kind of makes sense, but it's a little bit random.
Yeah,
where you would separate the subjects. But if I had to separate them, I think that's where you're trying to ask me.
Yeah. Well, it's just your opinion. But if you were to separate, how would you?
The best way to separate it would be,
because I feel like with sorry to interrupt, but with your kind of, when it comes to complexity theory and whatnot, there's a lot of I guess in my eyes, crossing the lines into physics.
Yeah. I mean, it's everything.
Yeah.
I mean, it's maths at the fundamental.
Yeah, I think it's a bit of maths, it's a bit of chemistry. But would you describe it as chemistry?
I don't think it's useful to describe it as chemistry or physics or math.
You don't think it's
I don't think it's a good question to ask. I think it's just
science.
The laws is just science.
Just science.
Yeah, exactly. It's the investigation of how the world functions. That's it. But again, you asked me if I had to divide them, how would I divide them? So biology is the study of living things.
Life, living things, organisms.
And I would like to give a qualifier whenever I say that, is the study of living things except at the very start of life. Because we don't really know what happened, or like the science. Because then you need physics and chemistry to explain what was going on then. And we really don't know how life began.
You don't fully understand it at the moment.
Chemistry is the study of atoms and stuff. So it goes down to the quantum and up into the life stuff. So it's like that in-between range against the leaves. And physics is the study of everything that we in our everyday lives, actually, I guess that wouldn't be correct, because we got classical physics, that, and also the theories of what we in an everyday life can't experience. So that's the very, very small and the very, very big.
Gotcha.
So that's how I would define it. But again, I'm forcing myself to do that.
I mean, these are some really good insights into science and into your own specific interests. But thank you so much, Musa. This has been an incredible
we're done already.
Conversation. Yeah. I wish I had more time.
3 hour long, like a Joe Rogan experience kind of thing.
We'll do a part 2 and maybe a part 3.
I hope so.
But yeah, thank you so much.
Thanks for having me.
Yeah, no, of course, man. So that's it for today's episode. Thank you so much for listening. And yeah, that was perfect. So make sure to follow us on Knowness app at Instagram, TikTok, Facebook, LinkedIn. I think I'm missing one more, but I can't remember it. And YouTube as well. But yeah, we'll see you guys next time.